So what is the importance of climate in the formation of peat? We all are aware that climate plays a very important role in the development of flora. Warm and humid climate or wet climate is important for luxuriant growth of flora and leads to more dominant forest swamps. So if the climate is warm and humid, it means the flora will be luxuriant, means very abundant and well developed. And warm and humid climate, it also helps in the formation of dominant forest swamps. If the climate is cold and it is relatively dry, then the swamp will be reed and moss swamp. These are all types of flora. So forest flora, reed and moss flora. So if the climate is warm and humid, the swamp will be mostly forest swamp. If it is cold and dry, you will be getting mostly reed and moss swamp. So the tropical latitude areas which have the warm and humid climate, they lead to the formation of these forest swamps, and we sometimes also call them tropical swamps. Tropical swamps. So what are tropical swamps? These are located in the tropical region, and you all are aware about the tropical climate, which is warm and humid. So the tropical swamp, they can renew the floral growth very fast. Renew floral growth fast. While if you have temperate swamp, means cold and dry, the renewal of flora is slow. So within the time when the trees of tropical swamps may grow up to the height of 30 or 40 meters, the temperate swamp may grow only up to 5 meters. So you can understand how important it is for the flora to develop the climate. Okay. Now, there are various types of bogs. We shall discuss the classification of bogs a bit later. But even the bogs are those places where the peats are formed. So bogs, moors, mires, all these are equivalent terminology. So the bogs which are poor in nutrients, sometimes you know what these nutrients are. These are the which increase the fertility of the soil in which the plants grow. So sometimes when the soils are poor in nutrients, they are called as ombrogenous bogs. So even sometimes the ombrogenous bogs have growth of the trees in the tropical region, while the ombrogenous bogs of the temperate region, they don't have the higher plants, they have only growth of moss. So you can understand that even if the nutrient condition of the soil is not very good, if they are in the tropical region, they may witness the growth of trees. While the ombrogenous or nutrient poor bogs of the temperate regions, they witness only the growth of moss. So you can understand this, that where there will be only moss, the peat will be different. And where there are trees, there the peats will be forest swamp. Okay. Now, in the geological past, the peats predominated in the moist climatic zone. So, for example, in the late Carboniferous time, where we find the richest coal formations, here the peats predominated in the moist and warm climatic zones. All right. But in the southern hemisphere and in Siberia, where there were temperate type of climates, there also we find some rare examples of rich coal deposits. Okay. So, even though the warm and humid climate is important, but in the temperate regions which have fairly good amount of rainfall, so we may have humid temperate type of climate. So humid temperate and dry temperate. So if it is a humid temperate climatic zone, like those in Siberia and in southern hemisphere, there also rich coal deposits have been found. So now we understand that availability of water is very, very important for the growth of plants. So the coal seams which deposited in moist, warm climate, they contain many broad bands of bright coal. So in the warm and moist type of climates, the coal seams which got deposited, they contain many broad bands of bright coal. And this bright coal, it is derived from thick stems, derived from thick stems, which means that the oven के ऊपर ही लगवाना, which means that the trees were very good. The growth of trees was very good during that time, while the coals formed in the uh, relatively cold type of climate, that is the temperate climate, when the climate is cool, in the cold climate, the coal seams, they contain relatively less bright coal. We will see later what is bright coal and what is dull coal. So why do the coal seams of temperate or cold climate, they are relatively dull? Because of the type of flora. In the warm and moist type of climate, you have large trees which have thick stems, and so the coal seams which are formed from these thicker stems, they consist of bright coal. While in the cold and dry type of climate, the coal seams, they are relatively thin, and they consist of less bright coal, only because of the type of flora. Now, as discussed, the warm climate not only increases the plant growth but also the rate of decomposition. So, on one hand, warm climate is good for the growth of plant. So, it increases plant growth. On the other hand, the warm climate also supports the rate of decomposition. So here it is faster decomposition. So we all are aware that if the decomposition will be faster and plant material gets decomposed, it will not lead to the formation of coal. So consequently, as a result, the coal seams of temperate region. So what does this imply? It implies that coal seams in temperate climate, they are thicker. They are thicker. Why? Because there the rate of decomposition is relatively slower than the warm climate. Okay, so the plant material gets relatively more preserved in the temperate type of climate, even though the flora of the temperate climate is not as luxuriant as the tropical climate. We have to understand this entire thing, that the warm climate is good for plant growth, but it is bad for the preservation of the dead plant material. I hope you are getting it. All right. So this is the basic idea about the importance of climate in the development of peat. The next thing that that is the most important, one of the most important prerequisites is the paleogeographic and tectonic requirement. Paleogeographic and tectonic requirements. So the prerequisites for development of thick peat deposits means what are the conditions? What are the conditions for the development of thick peat deposits? Conditions for development of thick peat deposits. What are they? First one is that the there should be slow, continuous rise of the groundwater table which protects peat from subsidence. Slow, continuous rise of groundwater table, it protects the peat from subsidence. So for example, as I had told you in the previous class that the peats are deposited in the areas of subsidence. So suppose that this is some basin where the peat is getting deposited, this material. And this area is a bit tectonically active, and this area may keep on subsiding. It may keep on going down. So this subsidence, it may lead to the destruction of this peat material if it subsides. To avoid this subsidence, if the groundwater table is present, then it would act against. So this is the groundwater table. So if the basin is going down and the groundwater table is rising up, so it will keep a balance between the rate of subsidence and the rise of the groundwater table. So what will happen if this groundwater table is rising continuously and slowly? then it will save this peat material from getting subsided and going to some depth where it might not get converted to coal properly. So the first thing is that the slow and continuous rise of the groundwater table, it protects the peat from subsidence. That is why groundwater table should rise continuously but slowly. Protects peat from subsidence. Okay. The second is the protection of swamp against encroachment of seawater. Protection of swamp against encroachment of seawater and river floods. So how does this work? Say for example, there is a swamp near a coastal region, and this area is protected or separated from the sea by, let us say, this is the beach area, and then you have the open sea. Now if this is the open sea, so what will happen during the tides, high tides, and due to the impact of waves, if this sea water starts coming in, if the sea water starts to come in and try to inundate this swamp, it will submerge the swamp. The sea water, it will submerge the swamp and it will destroy the entire swamp. So how this may be protected? The swamps may be protected against the encroachment of seawater by the beach, by the help of beach, by sandbars. So this, you may get some sandbars which may not allow the encroachment of the sea, and spits. All these are the geomorphological features in the coastal regions which may protect the swamp from the encroachment of the seawater, because if the seawater will enter the swampy region, it will submerge the peat, it will destroy it. And the third important prerequisite for the formation of thick peat deposits is the low relief energy, low relief energy of the hinterland and a restricted supply of and restricted supply of fluvial sediments. So we'll see what is this. Imagine that this is a mountainous terrain with very steep slopes, and in the foothills of these mountains, here, as I had told you yesterday, that mountainous foothills are very important sources of peats. So here you get the peat deposits. Now imagine that if the relief is high or a steep slope, it will be having high relief energy. So all this sedimentary material it will come down very fast and they will start to get laid deposited over the peat deposit. So high relief energy is not good for the formation of thick peat deposits. If the slope is gentle and the relief energy is low like this. So here low energy and restricted supply of fluvial sediment. So if the energy is low, then the movement of or transportation of the sedimentary material inside the peat will be slow and it will be better for the formation of peat deposits. Now imagine that there is some of this peat deposit close to a river area, the movement of river. If the fluvial sediments, now imagine that this peat or this peat has been deposited on the floodplain of the river and the fluvial sediments are coming in very fast. They will again get deposited over the peat and it will again not be good for the development of thicker peat deposits. Okay. So the restricted supply of fluvial sediments is another important factor where the less sediments may allow the peat to develop into thick peat deposits easily. Now, the first point which I told, slow and continuous rise of groundwater table. Why this should be slow and continuous? Let us also see. Now, in case of, let us say that this is the area where peat is deposited and it is subsiding very fast. Fast subsidence. So due to the faster subsidence of the of this area of this basin, the groundwater table, it will rise very fast. So as this groundwater table rises very fast, what it will do? It will submerge it will drown the swamp. So this is the swamp. इसको वो डुबा देगा. It will drown the swamp. And what will happen if the swamp gets drowned? So here large amount of lake or marine sediments may be deposited. So here you just saw that a restricted supply of sediments is important. So if the groundwater table rises very fast, then the swamps will drown. Swamp will drown. डूब जाएगा. While if the subsidence is very, very slow, okay, so both the conditions are there. If the subsidence is very slow subsidence, in that case, the plant material, slow subsidence will cause the plant material to decompose, to rot or decompose, and previously formed peat will be eroded. So if the subsidence is slow, the peat which was already formed over here, it may get eroded by the wind action. So they may be eroded. And the plant material which has freshly been deposited, since they will not be buried under the sediment cover, they will be rotting or they will get decomposed. So I hope you are understanding this. Now, if the groundwater table remains sufficiently high over a long period, okay, if the groundwater table is high over a sufficiently long period, then even if the climate was not fit for tree growth, the peats will also form. Okay. Such peats are formed in topogenic depressions that may form through water erosion. So, for example, oxbow lakes. Oxbow lakes are one of the good examples of the peat forming areas which are formed due to the sufficiently high and long standing groundwater table, or sometimes the topogenic depressions which are formed by the glacial erosion. So what happens? Glacier, it forms the topogenic depressions. The glacier melts. Those areas are filled with water. The plant material deposited over there. Now you can yourself imagine that the glacial places, they are not fit for tree growth because of extremely cold climate. But even in those cases, the peats may form from the smaller plants because of the sufficiently high water level. Some other areas of peat formation may be the craters of extinct volcanoes. The craters of extinct volcanoes, sometimes they form lakes. A very famous example you may find all across the world. Then sometimes the lakes formed, the craters formed by the meteoric impacts, that they also lead to the formation of lakes. So in such areas, if these lakes get filled by the plant material, they may give rise to swamp. Okay. So for the formation of peat, so you now saw the various conditions in which are important for the formation of the peat. So for the formation of peat, it is important that the groundwater must be stagnating. For the formation of peat, stagnating groundwater stand must stand for longer time, must stand for longer time above or near to the ground surface, above or near to the ground surface. Now what it will do, I'll just show you. So for example, this is a topogenic depression in which some plant material is deposited, and the groundwater table, the stagnating groundwater, it is sufficiently high, it is close to this area where it gets deposited, Now, what this will do, it will protect this will protect the deposited vegetal material. So this is all plant material, and if the groundwater is stagnating and standing for longer time, it will protect this plant material from, this is protect from decomposition. Once this plant material is it is covered by this groundwater and it is not allowed to come in the contact with the air atmosphere, then it will not decompose. Okay, so this is an important condition, and this is the role of groundwater. So groundwater protects the dead plant material from decomposition. So these conditions, they occur most frequently in the flat coastal areas where the seawater blocks the fresh water coming from land. This is the reason that most of the swamps, they are associated with the sea coast. Okay, they are associated with the sea coast. So most swamps are associated with sea coast. And why does this happen? Because sea water, it blocks the uh, incoming fresh water. So whenever fresh water will come and it will get drained in the swamp, it will bring large amount of oxygen with it. And we had seen that anoxic conditions are important for the formation of the swamps. Okay. Sometimes some other swamps, they occur on the shores of large inland lakes. Okay. Shores of large inland lakes, here also swamps may form. So you can see here that the water which is stagnating, which is logged at a place, that is the important condition for the formation of swamps. You cannot get swamps where there is running water. So you will rarely get a swamp in the course of a actively running river. You will not get that. Okay. So on the basis of the original geographical position, the coal, where the coal was formed, so the classification of the coal on the basis of geographical position. Classification of coal on the basis of original geographical position. There are of mainly two types: paralic coal and limnic coal. Paralic coal, it is the coal which is deposited at the sea coast, the swamps of the sea coast, while limnic coals are the inland lake swamps associated with the inland lakes. Inland lakes. Now, many of the paralic coal swamps, they originated on the distal margins of delta. So, the external distal margin of the delta, they are very good places for the formation of the thick coal seams. While now suppose that this is the shore and some river is coming in over here, and this is the open sea. So this portion may be the deltaic portion where the water of the river drains in the sea. So here, the central part of delta in this portion, the central part of delta, it does not give rise to true coal seams. Here, the peats may occur, no problems, but the central part is so rich in the mineral matter that mineral matter does not allow the coalification process properly. So the external distal part of the delta, they are proper places for the formation of the coal seams. Now at present, mangrove forests are the typical vegetation of the coastal margins of the delta in tropics. So so you all must be knowing about the mangrove vegetation, and in the coastal margins of delta in the tropics, the mangrove vegetation, the mangrove forest, they are very important vegetation of the coastal areas. Okay. Now, the swamps of the coal, they also advance, move forward and come back along with the transgression and regression. So the sea level rise and fall, I have told you about the transgression and regression processes. So during the marine regressions, so what happens during marine regression? If this is sea level 1, so during a regression, the sea level will fall, sea level 2. So what happens is that if the swamp was forming here, so with regression, this swamp will also move seaward because now this area becomes the deltaic region. Okay, so during marine regression, coal swamps, where do they move? They move seaward, advance seaward. Why? Because during marine regression, the delta, it moves towards the sea. Okay. So many coal swamps originate due to the marine regressions, while other swamps, they are formed during the marine transgression. Now, so what happens during marine transgression? So if this was sea level 1 and sea level rose, so it will inundate this area. So earlier, this portion was the swamp. Now, if the sea level has come over here, now this portion will become the swamp. Okay. SW means swamp. So, marine transgression and regression, they also play an important role in the formation of coal swamps. If the marine regression is happening, sea level is going down, the delta moves towards the sea. That is the seaward movement of the shoreline. Due to that, the coal swamps, they move towards the sea, they advance towards the sea. While if the marine transgression happens, then the shoreline, it moves landward. So several other uh, coal swamps, they are formed on the land due to the marine transgression. So I hope it is clear. In the northern temperate region, peat swamps often form in hollows of glacial origin. A very interesting thing. I'll just show you. Let me write here first. Northern hemisphere glaciated, or not glaciated exactly, let us call it temperate. Temperate regions. Northern hemisphere, temperate regions. What happens over here? So, in the cold climates, let us say that this is the glacier. As the climate will become more cold, the glaciers, they will advance, they will move ahead, move forward. So if this is the extent of the glacier, and this glacier starts to move forward, this is the snout or the nose of the glacier. So during the subsequent cold climates, the glacier, it moves ahead. Once this glacier moves ahead, what it does, it will of course be moving over some land area only. So if this is the continental part, this is the land area, due to the load of this glacier, and we all are aware that glaciers are very extensive agents of weathering and erosion. So what it does, the forward movement of this glacier, it causes the weathering and it leads to the formation of depression, topogenic depressions, which we also refer them to as the glacial depressions. So what happens now during the warm climate? Once the glacier goes back, warm climate melting of glacier. So now what will happen? The glacier will get removed from over there. It will melt. And therefore, you will get this land like this now. So you are finding here now some depressions from where this glacier was previously placed. So these depressions, these hollows of the glacial origin. So this, and this, all these are glacial hollows or glacial depressions. These in the temperate region, these are very common areas of the formation of peat swamps. If they get, and of course, the glacial melt water is also filled in over here. So pani bhi bhara rehta hai. Where that water is derived from? It is derived from the melting of the glaciers. So all these are very good sources of formation of swamp. So I hope you are understanding it. Now, as I had previously told you that peat deposits, they only remain preserved in the area of subsidence. If the peat gets in contact with the atmospheric wind or air, what will happen? The fresh plant material will decompose and the previously formed peat will get eroded. So no true coal seam will form. But in the areas of subsidence where the plant material and the peat, they get preserved and protected, in due course of time they will cause the formation of the coal seam. Now with the areas of subsidence, rich coal deposits are related, and therefore you will find rich coal deposits related in the four deep in front of fold mountains. So in case of fold mountains, for example, Himalayas, fold mountain region, the four deep, it is associated with rich coal deposits. Why? Because these areas, they are areas of subsidence and therefore the peats will be preserved properly over here. They are formed in continental settings. Continental setting in the areas of subsidence. So what will happen if, let us say, that this is a depression and there is some plant material, organic material. Over it will lie the sedimentary cover. So it will bury the peat. Then another layer of organic material will come in. Then again it will be buried by the sediment. Inorganic sediment. So this alternating sequence of sediment and uh, plant material, it is referred to as cyclothem. Most of the para Paralic coals, they get frequently deposited in 4 deeps, while limnic coals, they are laid down in large continental basins. Large continental basins.